Hi, I'm Jeremy Lecornu, and you might remember me from educational biology videos such as what is aerobic respiration and what is fermentation. But seriously though, I have made videos on those two topics and they're all about cellular respiration. They're the two different forms of cellular respiration. And cellular respiration is where cells break down high energy organic molecules like glucose to release energy. That energy then fuels the ATP cycle. And today's video, I'm going to answer the question, what is the ATP cycle? How does it work? And why do we need it? Let's get started. Okay, well firstly, what is ATP? ATP is this molecule called adenosine triphosphate. That's where it gets its name from, ATP. And it's a really important short-term energy storage compound in cells. It's made up of adenosine and 3 phosphate groups. That's where it gets its name, adenosine, tri meaning 3 phosphates. Now the third phosphate, I've drawn a squiggly line there to indicate that that is an unstable bond. That bond can be broken and ATP can be converted into ADP, diphosphate, and an extra phosphate group. When that happens, energy is released. Now remember, cells need energy to survive, and they need energy for things like movement and synthesis and active transport. So ATP enables cells to do those things because when it's converted into ADP, the energy that's released can allow cells to do those jobs. So here you can see in this diagram how that process works. First of all, I want you to concentrate on this bottom part here. This is ATP that we just looked at. 1, 2, 3 phosphates, so that's our ATP molecule. Squiggly bond showing that it's unstable. Now with the addition of some water, a hydrolysis reaction occurs and this phosphate is broken off. That means that ATP is converted into ADP. D standing for di, which means 2, and a spare phosphate group over here. So that conversion takes place, and when that conversion takes place, energy is released and it's used by the cell for the things that we just looked at. Synthesis, movement, active transport, all those sorts of things. Here's the catch. Cells need ATP continuously. They always require ATP to break it down to ADP. But if that process was a one-way process, we're going to run out. And that's why we need the ATP cycle. We need another step where we can actually put ATP back together and add this phosphate back on. And it just so happens that because breaking it down or converting the ATP to ADP released energy and was exothermic, meaning energy exits the reaction, adding the phosphate back on to make ATP again is an endothermic process, which means it requires energy, and that energy that is required to attach the phosphate back on and form ATP comes from cellular respiration, aerobic respiration, or fermentation. Check those videos out if you haven't already. So that forms our ATP cycle. The exothermic process of breaking down ATP to ADP and P, or converting it, and the endothermic process where energy needs to enter the reaction, which is attaching the phosphate back onto ADP and forming ATP. That cycle occurs continuously. And an amazing thing is the amount of ATP that actually gets recycled in this process. In fact, in one day, the equivalent of a human body weight of ATP is recycled in your body. Just think about that. So let's say you're 65 kilograms. In one day, your body uses up 65 kilograms of ATP. So let me ask you the question, why are you still here? Why don't you vanish in that day? You got it. It's because you produce 65 kilograms of ATP in that same amount of time. It's a continuous cycle. It's always breaking it down and regenerating it over and over again. So just one more way to look at it. I've got these three cogs here, or gears. Now, let's label these different gears. Now remember, if this one's moving, it will drive this one, and that will drive this one. Let's think of this first cog as cellular respiration, aerobic respiration or fermentation. Now, that starts moving and that process is occurring, and the energy released from that process drives the ATP cycle. So the ATP cycle is able to occur. And the ATP cycle is what provides the energy for cellular processes like movement and synthesis and active transport. What I want you to think about is, imagine if we take away the ATP cycle. That process is now not occurring. Cellular respiration can still be occurring as much as you like. But what's going to happen to the cellular processes? Is anything going to be driving those? No. They're going to come to a standstill. So without the ATP cycle, cellular processes can't occur, even though cellular respiration provides energy. It's a chain of events that is really important, and the ATP cycle fits in that really important space. So guys, that's been the ATP cycle. I hope that I've helped you to understand what it is and why we need it in our cells. Thanks very much for watching as always, and I'll see you next time. In all of my videos, I use information and material from the Biology Levels of Life textbook, workbook, and teaching notes. If you want any information on how to get hold of these, just leave a comment below or email me on jeremy.s.lecornu@gmail.com. Don't forget to subscribe if you want regular updates on my new videos. And as always, thanks so much for your support and positive feedback. I'm really glad that my videos are helping you.